Right, hello, welcome back to another video. Today we're going to be having a look at a couple of handy debugging functions that I've been using quite a lot recently, especially looking at things like normals, some complex maths things going on, all inbuilt to the engine, and yeah, give you some nice helpful information when you're stuck with your material that's not quite doing what you want. So first one we're going to be looking at is this one here, debug scalar values. So let's say we have a value. In this case it's just a simple parameter. If we visualize that as a color, well, we can see it's quite bright, but how bright exactly? Obviously there's going to be a big difference. It's going to start glowing a lot at 50, but there's no way I can tell from this image what this value is. Well, there is this function here, debug scalar values, just found in debug. The menu is an inbuilt function with the engine, and it gives us the numbers as a result. So there's a little bit of rounding error, Unreal's precision isn't exact. It can sometimes cause problems, but mostly it's okay. Obviously this is getting down right into the hundreds of thousands, but you can see here it's giving us 50. Really quite handy sometimes. Personally, it has an input here for maximum number of digits, and you can obviously just override that with a parameter or a constant. This is going to give us a much more cut down number. Personally, the default value of 8 is a bit high, so if we just double click and go into this, remember these functions, obviously you can go in and kind of like have a look around and sort of pick apart for your own interest if you want. This is, I think, is one of the better ones, nicely laid out, comments, etc. But somewhere we'll find a input. In fact, I might just use find input, input value number, input maximum number of digits. So this is set to use preview value as default, and the preview value is set here to be 8, and it's a scalar, so it's only using this one x component. So we could just overwrite that as 2. Maybe 2 is a bit low, maybe 3, and then just save. And that's going to save it to the engine. So this is it's not going to save to my engine because I've got it open in another engine over here, but that should just save to the engine, and then you'll be able to use that in all your projects, changing the default. So up to you if you want to go in and change those defaults, but you can if you need to. So yeah, so that's debug scalar values, pretty useful. What else might you want to use it for? So a lot of the mathematical operators, if I plug in time in here, it'll give me a value for how long my engine's been running, 537. Might be more than that, in fact. If I go up to 8, how's that going to go? There we go, that feels more like it. 11,550 seconds. So yeah, do be careful if making that number lower. If it goes too low, depends what you're trying to debug. But if we wanted to do something like a frac, we can look at it as a sort of visual component, we can see, but we can also debug it as a number component. So let's put this back down to 2 now. We are, so we can see, I know that a frac disregards the integer component, the whole number part, and just gives me repeating values between 0 and 1, and I can then visualize that here using my debug scalar values, which can be, like I say, really useful. Obviously, doesn't just exist for scalars. We have here debug float 3. If I plug a vector into that, it's going to give me my vector 3. So here my components are 0.5 in red, 0.2 in green, and 1 in blue, and you can see it's nicely color coded and split those out for us. Same thing, maximum number of digits, you can reduce that down if you need less accuracy. Really useful for debugging things like some of the input vectors. So the camera vector here, this is the direction the camera is facing. So here, if we look at our gizmo, I'm facing in the negative x, and you can see that here, negative x. Same. Oh, if I put this on the cube, I'm now looking down. I'm looking mostly in the z direction, or the blue direction, and so you can kind of quite easily debug what that vector's doing using these float 3 values. If I just plug that into emissive, turn off the previewing. Yeah, there's some stuff happening. Definitely visualize what's going on there, but personally I think that's a bit of a crazy rainbow. Whereas this, I can totally understand, okay, yeah, these are the numbers, they describe the direction that my camera is facing in, which is really useful. Obviously we have textures, so over here just a quick sample texture knocked together. A texture is a series of vector 3's, so what happens if we try and debug that? Well, it will give us a result. This is giving us a pure green result, so I'm not quite sure which pixel it's looking at there, but we can have a bit of a trick here. So if I plug in a text chord node, but in my text chord, instead of actually using any tiling, if I plug in 0, 0 in my U and V tiling, what we're going to get is that very first pixels. This is the top left pixel of my texture. Please close these, go back. And if I add to that just a couple of parameters, I can actually offset which pixel it is I'm looking at. So we've kind of made a pixel inspector, something you might sort of know from sort of Substance, that kind of thing. Unreal doesn't have one, sadly. It'd be quite nice, at least not to my knowledge, to be able to go here and kind of like get information about the pixel under the mouse cursor. Can't do it in the texture editor, but we can do it artificially in our material editor. So here, 0.1 offset and X, so I'm 10% into this texture, so I'm there. If I go up to, let's say, 0.3, this is going to go purely green. If I've done my maths right, there we are, and we're getting pure green. And obviously if we change this for something, let's say, I don't know, this concrete grime, we're going to be looking at pixel, and you can get the color values out of that. Could be really useful. Textures don't just have individual pixels. There's another way we might want to look at textures, and that is moving on to this one, the plot function on graph. So I'm just going to start this one from scratch. There are two others here, derivative and set of input. We're not going to cover those for now, just looking at plot function on graph. So this is actually used extensively in the math hall. So if you go to the content examples, I don't have Epic's launcher open at the moment. Well, on the Epic launcher, on the Learn tab, there is a thing called Content Examples, which is a really fantastic project that Epic provides. Has loads of examples of all the different features and functions that Unreal can do. If you want to learn about reflections, there's a level for that. And one of them is this one here, this maths hall. So if you want to learn about various mathematical functions, Epic has provided some of that for you. So you can go here for the absolute. You can see here it's taking the input values, which is this value here, this straight line, and it's taking the absolute, so it's ignoring all the negative points, and then it has a nice example on the other side of how that could be used. But this graph is actually just a material function. Here it's nicely set up with sliders and all this in the blueprint, but there's nothing stopping us, going back here, using that ourselves in our materials. So here it needs an input, f of x. If I just put in a parameter, I should get my graph and my value plotted on along it. So it's a bit difficult to see when it's on the origin, but if I plug in 0.2, give it a second to compile, we get this red line. So 0.2 has been plotted on this graph. We can rescale our axes as an input for that. So let's just do that, that's fine. So the default input, if you want to know what the default for a function is, if you just mouse over, the tooltip should give you the default values. And then we have -1, 1, -1, 1. So if I just change that to 0, 1, 0, 1, I'm just going to plug that in, and I'll get rid of those negative values. And we'll see, there we are, my graph has been recentered onto that. So depending on what range you're looking at, that can be helpful or not. So what kind of functions might we want to visualize on here? Well, if I take a sine wave, plug this in, I've now sort of run my parameter through a sine wave, got a different value. Not seeing it animate. I can scrub this value, but we're not getting a very realistic or very alive preview. So if I just replace that with time, we now have our value going all the way up, 0 to 1. This is the sort of the output of a sine. And what's nice about this material, or this function, it's using the UVs of the square. So if we take our sine or our time, and we just add the linear gradient, this is again just a built-in function. It's just using the UV components, masking them out into red and green channels to create linear gradients. These are mathematically derived gradients, so they're super accurate, super cheap. Definitely advise using them which I'm sure I have covered before, but here we are. If we take our time, add the U gradient to it, and then stick that into our sine wave, we get our sine wave kind of mapped out on our graph. So where this is really useful is if you're trying to create some kind of intermittent blinking effect, that kind of thing. Anything where you're trying to animate with maths and sine waves and curves like this can be really helpful to preview it as a graph, at least I find so. So if I just take my sine wave, if I, for example, multiply it by 2, that's going to go outside the ranges of my graph, but it's going to make it kind of steeper, and we'll see we're getting this bigger graph wave. If I then clamp that back to 0 and 1, and I am actually just going to remap this so I can see what's going on, and I'm going to remap it to -1, 2, -1, 2. Hopefully you can see here we've created this kind of hexagonal wave. So values clamp between 0 and 1, but they're kind of going up, and we're getting this kind of on, off. See it again here, but if we then take our linear gradient out of this, we're adding 1 to it, but that's not really making a big difference. And we've created this sort of intermittent blinking effect. We've done that purely with maths. We've been able to sort of preview exactly what's happening at all points, which I find a really nice way of sort of working. Similarly, that was that one. We can obviously just plug in textures. So if I have here a texture quick gradient function in Photoshop, if we plug in just the blue value to that, we can see we're getting here a mapping, or a 2D representation that's like a slice through this. Now in this case all the vertical pixels are the same, so the whole text is already kind of a 2D slice, but you can see now the sort of the height and the curvature and the fall off, and this can be quite helpful if you're doing things to your functions, to your textures. For example, seeing how a power node is going to affect that. If I do something like a time sine, and I'm just going to use that to lerp between. In fact, let's not do that. So let's do a debug sine, debug time sine. This is a really useful little function. Sine waves, as we saw up here. If I go back to that and then add in this, obviously go between 0 and 1. Obviously go between -1 and 1. The debug time sine, if I just plot that function, here we are. It's just been remapped to go to 0 to 1. There is a node that does it, constant bias scale, and the default values in here. This is just an add and a multiply together. And if we open up the debug time sine, you can see that's exactly what it's doing. Sine wave, constant bias scale, and it's just remapping those values. I mentioned remapping quite a lot. This is a really good way of visualizing it and seeing that. The only thing with the debug time sine, the default value for the speed is 0.5. I'm not quite sure why that default value is half rather than 1. But it is, there we are. But a nice quick way of doing just as a 0 to 1 value for debugging for exactly this. So here, if I want to debug what my power node's doing, if I do this, and let's say I go between 0 and 2, we get a nice kind of interactive preview of what the power node can do to our functions. You can see it's changing the sort of the profile of that, and how it's kind of changing things in the texture. So it depends on what you're doing, but it's a really nice way, I think, of sort of thinking about textures. Sometimes it's a bit easier to understand sort of the type of math you're trying to do in a graph form rather than in a texture form, and obviously these are just completely comparable similar things. What happens if our texture is slightly more interesting or slightly more noisy? So if I go for the Perlin noise that appears in here, this is going to be a bit of a mess. Let's just get rid of this power for a second. Might be a bit difficult to see. Obviously the amount of detail and noise in this texture is really high. You get a little preview of it at the top, but this is also trying to map this whole thing. Now we're trying to plot a function here. This function is only 2 directions, or it's only so we've got one sort of directionality to it, and this has got two, so we need to use the same trick as we did before, using a u value or a uv value of 0. So have that down here. If I just preview this one, so here I have my uv chords. If they're set to 1 1, we're trying to plot the whole 2D noise into a 1D scaled function. It's not going to make any sense. But if we take that, set the V tiling to 0, now we've just got a slice through the top. And the scale here is a little bit off. Obviously it's taking the whole texture and sort of mapping it to a graph all the way across here. So what can we do about that? Well, depending on what you're trying to debug, if we set this down to sort of 0.1, we're only looking at that first little section, and you can see those values being represented as a graph. And again, we can add sort of an offset if we want to make some control over that. And we can do the same thing with our power. So let's copy this, bring that down. So if I want to see my power node and how that's affecting the values in my texture, obviously we can just power stuff and see the values and see the result we're getting, but also we can plug it in here on a graph and preview it as a sort of graphed version in Engine. Really cool, pretty powerful, I like it. There is also this website that I would like to highlight. You might have seen me go here before if you've watched a lot of my videos. It's called Desmos. It is a maths website. There's lots of stuff on here, how you can draw images with graphs and things. We're not doing that, but we can just go in and start making our own graphs. So one example I always like is the combining of multiple sine waves to create noise. So if we have here two sine waves, sine x plus sine 2x, we can kind of see how adding multiple sine waves together creates a sort of slightly offset, more random pattern. And personally, yeah, I like to work in graphs occasionally, see what's going on, and there's a load of really good examples just inbuilt. Click the little 3 lines icon here, so we could say, I don't know, let's find one that's sort of interesting. Well, talking about sine waves, there's a trigonometry wave interference. Here we are. Just open this graph. You can see here we have two sine waves, and they've actually made a little animation. So how that sine wave, adding them together, you can see the sort of the resultant one here. That sine was getting kind of bigger and smaller and editing. So all they're doing, yeah, plotting those functions. Depending how complex your material is getting, there's definitely times when coming in and looking at functions in here and how that might work for your material, but also, as we can see, we can do things very similarly in Engine. Cool, hope that is helpful. I've definitely used them a few times recently to help debug some of my own work. As always, if you have any questions, comments, or would like to just get in touch, please do so. Also, I have a Patreon, so if you'd like to support the channel, if you like what I do, that is much appreciated. And I will see you all next time.